this lesson is going to be on writing in scientific notation, either taking numbers from scientific notation and making a number, or taking a number and writing it into scientific notation. Scientific notation just takes really small numbers or really big numbers and makes them into something that's a little bit more manageable, okay? And most of the time we use these things when we're dealing with measurements. Now, measurement is really simple. It's just a quantity that has a unit. So, for instance, if I wrote something like 2 grams, 2 would be my number, grams would be my measurement, or my unit, and therefore this number would be a measurement, okay? So what is scientific notation? Scientific notation is basically just a coefficient and a 10 raised to a power, okay? So again, let's refresh what a coefficient is in a number, okay? So this 2 out front would be my coefficient, okay? The times 10 to the is the power, is what the power is raised to, okay? So this would be 2 times 10 to the second power, okay? Now the power indicates how many times the decimal moves. To make the number either really big or really small, okay? Now let's talk about a couple of rules within scientific notation. Okay, so the coefficient has to be between 1 and 9.99. You can't have a 0.5 coefficient, you can't have a 50 coefficient, you just can't do it, okay? If the power is negative, that means that the number is between 0 and 1, meaning you're dealing with a very small number, or a decimal. Okay? If the coefficient is negative, though, this does not necessarily mean that the number is negative. So, for instance, if I had 1 times 10 to the negative third, that does not mean that this number is negative. It means that it's really small. Now, if I put negative 1 times 10 to the negative third, that does mean that the value will be negative. Okay? If the power is positive, the number is going to be greater than 1. And if the power is 0, then it's just the value of the coefficient. That means if you have a 0 exponent, it just means that the coefficient hasn't moved. Or I'm sorry, the decimal hasn't moved at all. So if I have 5.0 times 10 to the 0, decimal doesn't move, therefore I just have 5.0. Okay, now I'm going to do some examples that aren't within your notes, so you can have extra practice within your notes, and I want to see if we can develop some hints to help us with writing scientific notation. Okay, so let's take a number first and then write it into scientific notation. Okay, so we're going to do a number to scientific notation. So let's say that I have something like 5,700. So there should be a couple of questions that you're asking yourself. Is this a big number or is this a small number? Obviously it's a big number because it's greater than 1, okay? So I know that I'm going to have a times 10 to the positive power. Okay, now there's no decimal present, so I'm going to put the decimal where it would be known. So like if I was to type this into my calculator would automatically put a decimal past that 0, okay? Now, my coefficient, this guy out here, has to be between 1 and 9.99. Where do I have to move my decimal to get a number between 1 and 9.99? Hopefully you said between the 5 and the 7, okay? Because now my coefficient is going to be 5.7. Is that number between 1 and 9.99? The answer is yes. Then that means that that's going to be our coefficient, okay? Now my power is how many times did I have to move my decimal to get that coefficient, okay? Well, let's see. So here's where the decimal starts. This is where the decimal ends. So let's move it until we get to the 5.7. So I'm going to go 1, 2, 3. So I had to move my decimal place 3 times in order to get my 5.7 coefficient. Therefore, my power is to the third. So my number here is 5.7 times 10 to the third. You can either put the positive or not put the positive. We know that the number's positive if it's not there. Okay, let's do one more. Let's try 523. Again, no decimal present, so I have to put it where it would be known. Okay, I know it's going to be a positive exponent because it's a big number, greater than 1. So it's going to be times 10. 523 is not between 1 and 9.99. Can I put my decimal here? I hope you said no, because 52.3 is not between 1 and 9.99 either. I'm going to have to put my decimal place right here between the 5 and the 2. Okay? So now my coefficient is going to be 5.23 or 5.2. Okay? So now I'm going to move my decimal place 2 places. Therefore, my power will be times 10 to the second. Okay? Now let's look at going from, let's do a small number first before we go from scientific notation to number. So let's try 0.00018. Okay, big number, little number. Little number. So I'm going to have a times 10 to a negative value because my number is going to be between 0, or my number is between 0 and 1. Okay? Now, where do I have to put the decimal place to get a coefficient that is between 1 and 9.99? Well, I have to put it between the 1 and the 8. How many times do I have to swoop my decimal to get that coefficient? So here's my coefficient. And I'm going to go 1, 2, 3, 4, 5. I had to swoop 5 times. Therefore, my power is times 10 to the negative 5th. Good? Let's try one more. Let's do 0.53. Okay? Small number between 0 and 1. So I'm going to do times 10 to the negative value. My coefficient has to be between 1 and 9.99. So my coefficient is going to be 5.3. And I have to swoop once. So it'll be a negative 1 value. Okay? Right. Okay, now let's go from scientific notation to a number. Okay, so now we're going to go from scientific notation to a number. All right, now what if I had something like 8.36 times 10 to the negative 6? How do I write that as a number? Or what does that even mean? Okay, let's diagnose this. So this is a negative exponent, which means that my number is really small. Okay. The power indicates how many times the decimal place has moved, okay? So if I have a small number and the decimal place has moved 6 times, I have to add the zeros out front of the number to make the number even smaller, okay? So I'm going to do that. So I'm going to go 1 swoop, 2, 3, 4, 5, 6. And that's where my decimal place should end up. Okay, now I have these swoops that I now have to fill with zeros because that indicates that my number is small. So I'm going to go 1, 2, 3, 4, 5. And that kind of makes sense, right? Because the decimal started past the 8. And if I'm swooping 6 times, that means that there should be 5 zeros in front of the 8, and there is. So this number then turns out to be 1, 2, 3, 4, 5, 8, 3, 6. Okay, so we just put that back into a number. Good? Okay, let's do a different one. Let's do a big number. Let's do 2.31 times 10 to the 3rd. Okay, positive power, meaning I have to make my number bigger. Okay, so I'm swooping the decimal place to make the number bigger. I'm not going to now add the zeros in front. I'm going to add the zeros behind to make the number bigger. So I'm going to do that. So I'm going to go 1, swoop, 2, 3, which means that the 0 is going to go past the 1. Okay, so I'm going to have 2,310 as my new number. Now that kind of makes sense, right? Because I had to get past the 3 and the 1 before I could add a 0. So that indicates that 3, 2 numbers, 3 minus 2 is 1, 1, 0. Okay? All right, last one. What if I had 5.6 times 10 to the 0? What would that be? Well, I have a 0 exponent, which indicates that I'm not swooping at all. Therefore, my number would just be 5.6. Okay, so let's kind of draw some hints here. Some things that I said that aren't in your notes. So let's say the power indicates places decimal is moved. Okay, now let's go up here. If I'm going from a number to scientific notation, okay, and I have a big number, I'm going to be swooping to make the number smaller. Okay, so I'll be swooping to the left. If I have a small number, I have to swoop to the right. Kind of the same thing down here. if I'm going from scientific notation to a number, and I have a negative exponent, that means I have to put the zeros to the left of the number. And if I have a positive exponent, that means that I'm going to be making the number bigger, which means the zeros have to go behind the value. Okay? Now, why don't you go ahead and try and practice the problems within your notes, and take notes, and you'll have to let me know if you have any questions. Thank you.